So to summarize the text that you've been reading about waves and oscillations, I think a lot has been said in the book about waves, but not so much about oscillations. And of course, an oscillation must be the source of any wave. You wouldn't be able to get any wave at all traveling from one place to another without there being an oscillation, something moving side to side over time or up and down in order to produce them in the first place. Now, as the book suggests, there are two types of waves. Well, first of all, even before thinking about two types of waves, let me remind you what waves are. Waves are ways of conveying energy. They are ways of conveying energy from A to B, conveying energy from one place to another without material moving from A to B, from that one place to the other, without matter moving from A to B. That's effectively what any old wave is. There you go. That's it. Ways of conveying energy from A to B without matter moving from A to B is essentially what all waves are. The source of all waves is always an oscillation. So the second thing I'll mention, source of all waves must be something oscillating, which means oscillating, something moving up and down and up and down and up and down like that. And a graph of actually an oscillation against time would be something like that, as my finger very cleverly moves from left to right and also up and down at the same time. That is a graph of something's displacement against time showing an oscillation. Yeah, and I got this thing here. Source must be an oscillation. There we go, what I wrote there. So that's a graph of an oscillation. But of course a graph of a wave would look something different. It would look like this because the axes would be different. If you were to freeze a wave in time, then the wibbly-wobbly nature of a wave would be, of course, that would be a distance along axis. They look the same shape, but because the wave axis is distance, but the oscillations axis is time, they are entirely different. And so I suppose I could actually ask you, what is represented by that line AB, and what is represented by this line here, XY? And what are the answers to those two questions? Just think a bit about what those answers are. What is represented by AB and what is represented by XY? Well, in the case of AB, it's the time for one complete to and fro. The time taken, because the horizontal axis is time, the time taken for a complete oscillation to occur. What is represented by the line XY? And the answer is, it's a distance between two peaks of a wave which is displayed on a picture, on a photograph, say, at one instant in time. And finally, just to remind you, there are two sorts of waves, transverse and longitudinal or longitudinal, doesn't matter how you pronounce it, transverse and longitudinal, as I think the textbook has gone through or mentioned when you were reading the pages just prescribed for you. I think that will do, and then I'll give you some questions now based on that basic work on waves and oscillations.